A new chapter. We're moving on to multivariate functions. And the first section we're going to do is actually called that. So we have multivariable functions. Do a little bit of kind of intro to it before we look at what the kind of questions that you're asked to do. Right. Before Calc 3 came along, the only real functions that you would deal with would be ones that essentially look like that. That would be things, very simple example would be x squared. And when you graphed it, for every value of x, there was a corresponding value of y. And you would graph it and it would look like that. We also sometimes call it y equals x squared. And they're totally equivalent. They don't mean anything different, right? So if I said to you f of x equals x squared or y equals x squared, I'm talking about the same curve, right? They're the same relationship. Now, in the world that we're talking about, this is really a two-dimensional situation, right? It's a curve in 2D space. Now, when you move into, in general, the ones we're interested in are going to be three-dimensional spaces. Your function takes on a new shape. There are now two variables, typically called x and y, and they might be equal to something, say, like x squared plus y squared. You will also sometimes see it written as z equals x squared plus y squared. And these are called multivariable functions because there are two variables, x and y, are totally independent of each other, right? X and y can be any numbers they like. But whatever value x and y is, the value of the function in this case is x squared plus y squared. If you wanted to plot all the points in three-dimensional space that have this property, that their z coordinate is equal to this, then what you would get is a shape something like this. Well, for starters, you don't get a curve. What you get is a surface. In fact, this particular shape, the surface, looks something like a parabola bowl. It would look something like that. So any point on the ground, if you square its x coordinate and then you add its y coordinate squared, that number, if you plotted it, so if you had a point here, like imagine that was a point 2, 1, it would have a value of 5. And so you would plot a point 5 right above it. So can you imagine that any given point, there's a z value associated to it. So any point in xy plane, you go up. And we are going to be interested in these types of functions, these multivariable functions, typically these ones. And what you end up with is a surface in 3D space. And the surface is actually all this stuff, right? Now how well I can do this. So it's not the whole thing, it's just the shell, right? The outside piece, right? The inside is just hollow. It has no value that we are interested in. So that's kind of what a multivariable function looks like. It's a surface, which we almost always will use GeoGebra because they're too hard to imagine in your head. So let's look at what we mean by a domain. Well, if I return back to, college algebra level, and I said to you, y equals x squared, or if you prefer, f of x equals x squared. If I asked you what the domain is, you're really looking at the usable values of x, right? So for that function, the domain is actually everybody. And you can write down the domain in interval notations like that. And you can also, although we've never really used it in this context, you can also use a big letter R. You ever seen that funny looking R? That just means all real numbers, which is equivalent to that. Of course, if you get a function that has some kind of restriction on the domain, so for instance, a square root function, if I asked you for this function's domain, you could only choose values of x that make this expression that's inside greater than or equal to 0, right? You can't find square roots of negative numbers and get real values, right? We only pretend that real numbers exist for these. So if you want to find its domain, you would need to solve when is this guy greater than or equal to 0. If you add 8 to both sides and then divide by 2, your domain ends up looking like that. And in interval notation, we would write it typically like that. We're quite familiar with domains, right? Now, at the same time as you have a domain of a function, you can also look at what's called the range of that function. The range is essentially the range of answers, right? The range of y values. If I draw a little baby picture of that guy, would you agree that the range of this function is any number from 0 onwards to infinity? Now, if you were looking at a square root function, even this one, although it has a strange domain, if you sketched it, it would look something like that. Its range, also by sheer coincidence, happens to be all the numbers from 0 to infinity. In other words, this expression here, the smallest answer you'll ever get out of it, no matter what value of x you pick, is going to be 0. And the biggest answer could be anything you like, because there's no limit to how big it could become. So we have domain, usable values of x, and we have range, which is essentially the range of the answers, right? The range of the y values. Now, when you move on to multivariate functions, for instance, this guy, the domain comes a little bit more difficult to explain. It's not usable x values only, and it's not usable y values only. Isn't it usable values of x comma y? In other words, what usable values could you know, would be x and y? So in this case, couldn't the combination of these two numbers be any value for x you want and any value for y? So how do you write down two variables that could take any number? Well, you could write it, I better put it as domain. You could write the domain something like this. All the numbers from negative infinity to infinity, and then you put, it looks like a cross product, but it's not. You just put a cross, and then you do all the numbers from negative infinity to infinity. And the convention is that this represents the x's and this represents the y's. Now there's another way you can write that same answer down, and you write it as r squared, which is much more convenient. What that means is essentially, because I've seen it written in other textbooks as r cross r, it means the same thing as what we have above here. Imagine I have a function and I tell you that the domain is 0 to infinity cross -1 to 1. If I said I have a multivariate function and this is its domain, won't this part tell me that x is somewhere between 0 and infinity, essentially? So you can't pick negative numbers. And doesn't this tell me that y can only be values between -1 and 1? Are we comfortable with what a domain looks like in a multivariate function? It's a combination of what x is allowed to be and what y is allowed to be. And whatever x is goes here, and whatever y could be goes here. And you kind of use this x notation in the center to separate them. Oh, well, I'll come back to the range in a minute. Here's another function. And I would like to find out what its domain is, right? So I want to know what the domain of this function is. Right. if you use x squared plus y squared, would you agree you can use any value of x or y you like and it'll work? So that basically means anybody R2 is a short way of saying that. On the other hand, since this also contains a plus square root of y, doesn't that mean that y must be greater than or equal to 0? Now, when you put this guy and that guy together, what you end up with is that the x's can be anything they like, but the y's have to be 0 or above. You would also write it slightly shorter notation by using that. So whenever I use that, it just means that. So the domain of a multivariate function is going to be what the x's can do cross what the y's can do. Are we good so far? Okay. Now, let's talk about range. The range is a single value, a single interval, because x squared plus y squared, right? What's the smallest number, no matter what x and y you pick, what's the smallest answer you're going to get out of x squared plus y squared? And there is a number.
Is it 1?
No, you can do less than 1.
0.
Yes. Can you get 0? X is 0, y is 0. Would you agree you could never get a negative number out of x squared plus y squared? On the other hand, couldn't x squared plus y squared be as big as you like? Just pick a big x and a big y and it can grow forever. So do you notice that the range doesn't have that cross thing going on? Because the range is essentially what the entire expression could be equal to, right? Are we good? Right. If I just gave you this guy, because I want to get mileage out of this, if I just gave you this function and I asked you for the range, okay, would you agree the range is -1 to +1? Because a cosine can never be less than -1 and a cosine can never be more than +1. So if that was the only function we were dealing with, the range would be -1 to 1. Now, stick this guy in. Well, couldn't that be anything starting at 0 and going to infinity? That is -1 to 1. That could be 0 to infinity. If you put the whole package together, then you can actually say that this entire expression could be as low as -1. Right? Because couldn't this be -1 and that be plus something like 0, right? If you pick the right choices. For instance, how about making y equals 0 and x equals the square root of pi upon 2 or something? You could make it -1. On the other hand, couldn't it be as big as you like? So there's your range. So if that was the only function, the range would be -1 to 1. You introduce this, it's still -1, right? Because that could happen. But on the other side, couldn't this guy make the answer bigger than 1, right? You could have the square root of 50 and that would be bigger than 1, or a million, or a trillion. Are we good?
Okay, so the y could actually equal -1. Is that what you're saying?
No, I'm saying that
The
this piece
function.
could be, yeah, this function, the whole thing could be -1.
Okay.
For instance, if you make y 0 and x, how would I get -1? Pi upon 3 pi upon 2. It's a weird one, but if you made x the square root of 3 upon 2 pi, right, you would get 3 upon 2 pi, which is plus 0, and that could become -1. So you could get -1 out of this, right? You just make y 0 and x. Now, that's why -1 is possible, and any number in between. And this guy takes over. Once you've left the -1 to 1 range, which is what this can do, can't that make things bigger than 1? Pick y is 10, 10 million, 10 trillion. So that's basically why the answer to the whole expression. See, if that's 10 trillion, it doesn't matter if that's 10 trillion take away 1 or 10 trillion add 1. Would you agree it's still going to be massively big and could keep getting bigger? Are we good? Right, now let's kind of show you what the heck's going on here. There's a lot of, well, you'll see. There's a lot of stuff going on here that really is visual. We haven't talked about it yet, but you're going to see it in a few moments. Right, here is our group of questions. I'll try and make this a little bit bigger. Are you looking at question 1 right now? Right, so here is our multivariable function, right? It's what? Cosine of x add 2y. So if you're asked to evaluate this expression at that point there, aren't you basically going to be finding, well, let's type it in, it shouldn't be too hard to do, the cosine of x, which is 2, plus 2 lots of y, plus 2 lots of -1, which actually is just the cosine of 0. And the cosine of 0 is equal to 1. So the bottom line is that thing is equal to 1. Does that make sense? Plug x equals 2 here. Plug y is -1 here. And you end up with the cosine of 0, which is 1. Okay. Now, this function here has a domain. That's usable values of x and y. Would you agree that you can use any x and any y you like inside the cosine? You're going to get a number, right? The cosine of 50 million or minus 50 million does exist, right? You could get a value for it. So there's your domain. You see they're using the r squared, any value of x cross any value of x, y. Now, what is the range? Okay, the entire function. What is the range of answers you could get from a cosine of x plus 2y? Actually, from a cosine of anything. What's the smallest number you could get?
-1.
-1. What's the biggest?
1.
That's your range. Did you agree the cosine, no matter what number you put in the cosine, isn't the smallest you're ever going to get is -1. And the biggest you're ever going to get is 1. So in this case, your answer, square brackets, would be -1, 1. Now, if I asked you to do a sketch of this guy, do you see that there are 4 pictures? Now, we know that multivariate functions generate surfaces, right? The skin of a 3D surface. Let's take this guy. Well, let's see if we can do the answer before we actually let GeoBra prove it to us. If you took all the points in 3D space where the z coordinate, think of that as the z coordinate, is equal to the x coordinate squared, wouldn't you get a parabola shape, just like x squared? So it's either going to be this shape or it's that shape. Now, when you look at this shape, if you look at it from this direction here, right, from the left coming in, can you see the big happy face? So my prediction is it's going to be that shape. So what I'm going to do now is find GeoBra. Are you looking at GeoBra, or will I have to go out and in? You can see it? Okay, I'm going to type in the shortened version. So you can always call it z equals, not with a capital you can, z equals, and the guy that we had was x squared. And does that look like the shape I said it was? Box number 1. Now, one of the advantages of GeoBra is if you look at this axis here, right, and you turn it on its side, do you see it? Yeah, do you see that x squared kind of shape? Now, if you look at it from above, doesn't it look like a rectangle? It's actually a rectangle that's curving down and up. And if you alter, different orientations, it looks like a rectangle this way. If you turn it a little bit, you can see the quadratic. And that was that.
Yeah, if you
So-
laid it out flat, it looked like a rectangle too.
Yeah, like that way. Is that the one you're thinking? That way. If you look at it from underneath, it looks like a rectangle as well. GeoBra gives you a lot of views. The key to realizing this one is to notice that the red one is the x-axis. So if you turn it, can you see vertical is the z and horizontal is the x? Can you see the z equals x squared kind of cross section? Now I'm going to put next to it the alternate, which is that guy. And I hope it has a different color. No, it's both red, so I should be able to change the red color. Now you can see it. Right, that's the x, z equals x squared. That's the z equals y squared. Can you see the difference as the axis that it uses? Still got the basic shape, but now you have to orientate it this way. Let me make that go away. This way, and this is the y-axis, and there's your z. Can you see the z equals x squared? Now I need to go hunting for our guy. So suppose you wanted to do this fella. 2 take away x squared, take away y squared. Essentially, you just put it into GeoBra, and one of these four shapes is going to appear. It's going to be one of these two, that I know. Want to have a guess before we do a picture and see what it looks like? What do you think z equals 2 take away x squared, take away y squared might look like?
It's the one you're looking at on the left, I think.
Right.
But I'm
So
not sure.
You're not sure. But if you look at that, do you notice that you're subtracting x squared and subtracting y squared? Wouldn't that have the tendency to make the curve go down the way, which is the one you're picking? Does that make sense?
Yeah.
Right.
And
Now, if you
two.
And it's going to start at 2, because at 2, the x and y are 0, right? And so you've got 2, and everything else is going to be less than that. If you wanted to make this shape, do you know the only change you would make is plus x squared plus y squared? Right, so this one on the right would be same formula, but plus and plus there. Right, well, that's our prediction. You would go and you do a GeoBra on it. So where are you, GeoBra? Here we are. Delete and delete. And I'll do a z equals, and I'll paste it. And of course, I have to tweak it a little bit because it doesn't remember the x squared and the y squareds. And there you go. Can you see that shape? The top left-hand corner. Now I went and said that if you, let's copy this one and do a similar function, but these two are now going to be added. Okay, it should do it. Yeah, easier to see it in two different colors, right? Do you see the shape hasn't changed so much as its orientation? Interesting. Now, since I've got this function in front of us, I'm going to copy this one. I'm going to put it here. I'm going to make those two go away so they're not a distraction. And I'm going to change this guy here to that. Now, what do you think that might do to the shape? It's quite hard to predict. Let's show you. Wow. There, can you see it looks a bit like a saddle?
Looks
The
like
horse.
the shape that the like the Pringles are?
Oh yeah, yeah, saddle shaped little Pringle thing. Yeah. And so do you notice that just changing the sign of one alters the shape a lot, right? That's not really that's not anywhere near that guy. Yeah, you see them together. In a funny sort of a way, doesn't the blue guy fit the hole that the other guy left? Right? That's kind of interesting. And continuing. So can you imagine that a lot of your homework questions are going to be put Z equals in and then pick the right picture? Now, if you put this guy in, one of these four shapes appear. I believe it's that shape. Now, the next group of questions are, here are four surfaces, and here are the, is it four or six? Here are six surfaces, and here are six functions. So it's one of them, each one has one of the pictures. So I'm going to pick, I don't know what one I'm going to pick. Kind of like the looks of that one. Something weird's happening at 0. Yeah. See this function here, the natural log of x squared plus y squared? It ends up looking like this guy here. Now, why would that happen? Well, what happens if you try and get the log of 0? Right, just a normal log of 0. Isn't the answer minus infinity? Right, the curve zooms downwards. This here is like a vertical asymptote in 3D space. Right, let me show you that one. It's such a cool one. That way in GeoBra, at least we can see it. So I'm going to do Z equals, I hope it'll take natural logs. Change that to x squared. Change this to y squared. There. Can you see that gravity well?
So
Mhm.
why does it do that again?
Oh, if you look at the, let's do it from this position. This guy right here where my thing is, isn't that the origin? That's 0, 0 on the floor.
Yeah.
Now, as you get closer to 0, 0 on the floor, doesn't x squared plus y squared get really, really close to 0?
Yeah.
And the natural log of 0 is negative infinity. So the z value becomes closer and closer to negative infinity in any direction you choose to get closer to 0, 0, right? So it's a 3D, it's coming together from any direction, like coming in from all the directions at once. And it's generating this really weird. Now that thing there actually continues to get narrower and steeper, because as you're getting narrower, aren't you getting closer to 0, 0? And therefore the log is getting closer to being the log of 0. That makes sense? It's a very interesting function because what it shows you is an example of a vertical asymptote in a 3D surface, right? Because a vertical asymptote, didn't it used to be in pre-calc 1? Just a vertical asymptote looked like that, right? Just be a curve. But can you see in the 3D world, it kind of is a curve, but isn't it a curve that you can rotate? It's going vertical in every direction. Really cool shape. So what your job will be in this question essentially is put this guy into GeoBra and then match it to the curve. So I've already figured that one out is what curve number 4. So you would just say 4, right? Do the others. Let's see if we can pick one. CF, the cosine of xy. Which one of those 4 shapes or 6 shapes is the cosine of xy? Any ideas? What about that one? That's my guess. I'm pretty sure it's that one. You'll find out. Right. Now, for the military people amongst you, although some of you do it anyway, there is a thing called a contour map, also called a level curve. I like the word contour map. And basically what you have is a 2D map where anything of similar temperature, points of similar temperature are joined together with curves, right? The most likely ones you're seeing if you're in the military isn't a map of the area. You know, I'm sure the military still give people paper maps because you never know when the signal's no good, right? You have to be able to read a map. And a contour map allows you to see 3D on 2D paper, right? So in a contour map of terrain, don't they join points of equal height together, right? So this curve is 40 feet, this is 50 feet, this is 60 feet. And if you know how to read a map, can't you tell things about that's a hill, this is a valley, that's a steep hill, this is a very gentle hill, right? In this particular one, they have got a lot of information on this one diagram. You won't be able to read in any detail, but you will be able to read it. What this curve does is along the x-axis is the day of the year, right? So for instance, May the 20th was called day 140, which would be here. Vertically is the depth. And this chart tells you what the temperature of water would be on any given day in 1998 at a depth somewhere between 0 and 15 feet in a lake. Is it feet or meters? Meters in a lake. So let's see what we can do. Estimate the temperature in a lake on day 140 at a depth of 10 meters. So 140 is here and a depth of 10 is here. Now, if I put my mouse roughly where I think those two cross, would you agree they cross pretty near that line? And since it's an estimate, that line has an 8 on it. So that means the temperature would be 8 degrees centigrade. Do you see how we read this thing? 8 degrees. Now, what about day 140? Which also happens to be that one, but I think you'll get different days. At a depth of 5 meters. Well, if you do 5 meters and you do 140, I'm thinking the answer is about here. Now, it's not on the 12 line, at least my estimate is not. But if you look at the next line, it's 16.
more like the middle of 12 and 16.
So you call that 14 then, right? If you think it's a little bit closer to the 12, call it 13. If you think it's a little bit closer to the 16, call it 15. You're not going to get any more accurate than that, right? Nearest whole number is the best you're going to get. So you can imagine that that actually contains an awful lot of information, and contour maps can be really helpful. Here is a contour map of a function, right? A surface. So the way you read it is, imagine that you slice the shape horizontally, starting maybe at a height of 10, then 9, then 8, then 7, then 6, then 5. And each cut, won't you make a shape? So I'm looking at this shape here. It's made up of concentric circles. Which one of these 4 surfaces would make that contour map appear? I think it's pretty straightforward. You see lots of circles?
I'd say
Ah.
the pyramid.
Well, if you take, well, let's try why I can maybe argue why it's not. If you slice that pyramid vertically, won't you get rectangles or squares?
Oh yeah, that's true. That's true.
Right. Now, I don't know what you get if you slice that, but I'm pretty sure it's not circles. And I'm pretty sure if you slice that, won't you just get big, happy face shapes?
If it's the third one.
You agree it's the third one?
Yeah, it's the third one.
Now, here's that guy. Now, Calvin, you're getting this question. Which one of these same 4 shapes would do that with?
It's kind of ironic that it's the third selection again.
Right. but it's a pyramid as well. Are we cool with that? Now, what happens when they give you a question like this? So there's no surface, and they ask you to pick which one of these is the correct contour map, right? So what you need to do is you take this guy and you put it into GeoBra, and GeoBra is a big thing today. Is that the right thing? Yes, it is. Okay. There we go. Right, can you see that shape? Now, if you look at it, this is a toppy Z looking down towards the ground, right? This is me on an aircraft looking down on it. Can you see that this shape, if you slice it at 5 feet, 10 feet, 15 feet, 20 feet, won't you just get a whole load of ellipse-like shapes? Right? Now, keep that thought, and let's see what our choices are. And I think I can see the one that has a whole load of ellipsoid shapes. Does that make sense? So you need to see the surface before you can really make an intelligent prediction on what the contour map would be like. Share some things with you. When I started doing stuff on 3D, it's a long time ago, we didn't have Desmos or GeoBra. Right? The calculators we had square root buttons on them, and you were lucky if you got a trig function, right? So we had to do this essentially by visualizing and by creating from scratch a contour map. And you might think, well, how on earth do you create a contour map? You just say Z is 5, Z is 10, Z is 20, and what you end up drawing is lots of ellipses. And if you do enough ellipses, you'll realize it's that shape. So aren't we lucky that we have GeoBra? I mean, it takes away a lot of the need to know what something is. And I believe that was the shape, wasn't it, that we got in GeoBra? Right. Question 10. Here is the function. Oops. One of these 6 guys is him, right? Right. If you plug this guy into GeoBra, you'll be able to find out which one it is. And once you've figured out which one it is, won't you be able to then tell me which of these would be its contour map? And I can't remember. So I'm going to copy that one. Oh, anybody got a prediction? There's A, B to F. Which one of those 6 do you think is going to be the contour map of sine XY?
I want to say C or maybe E.
And would I
say E.
Right. I'm going to put your thought process in for you. Are you thinking because it's a sign that's going to repeat itself over and over again, because that's what signs do, and those shapes look like they've got repeating features to them? Is that your thought process?
Well, kind of. It's also because when I think you did the cosine one, it kind of it almost had like the same sort of resemblance.
Okay. So I've seen ones like it and they look like this, and so I'm going to just, you know, assume that if something is similar, it probably is going to look the same, right? Which just seems a reasonable assumption. Let's find out. Oh, interesting. See that?
It was like
So
it's like one point of contact, but it's ripples.
it's like ripples. Yeah, I think that's a good way of describing it. So I'm going to go back and figure out which one looks like ripples. Actually, it ends up being F, doesn't it? Would you agree that's the closest to being ripples? Was there another one?
That or C.
That or C. Right, let me find out. Because they didn't give me a lot of clues on that. Let's find out that or C, what you look like. Which one is the dot in it? Did they say? I got a solution, that's 10. 10 has a solution to it, right? Click 10. Oh, there it is, it's C. They put the answer down here. It's C. And then you can describe it. Here's a function. One of these guys is going to be that function. Here's another function, one of these. Here's another function, one of these. Isn't this basically type them into GeoGebra and look to see what you get? And hopefully, if you type in this one, it will look, well, I've got the answers. It looks like that one.
I have a quick question, just going back to all those different graphs that you were at. Keep scrolling.
There we go. That one?
Well, it was the one after that you were just kind of looking through.
This one.
Just a little bit. Yeah, this one, but just scroll down a little bit further. A little bit more. A little bit more. What's so these two, not those two, but just the ones directly below it. What's the difference between these two? Because they look almost exactly the same.
There is very little difference except one of those rotated about 90 degrees. That's about all I could say. They look like little, you know, the bottom of a handkerchief. No, the bottom of a parachute turned upside down.
Yeah.
And this parachute has the spike here, and this one has it slightly off. I'm not saying, I can't see a lot of difference. So I'm assuming that neither of those are the right answer. Or if it's not the first one, you just pick the other one, right? So these guys are pretty much, put them into GeoGebra and choose whichever of the 4 pictures it should be. They don't have axis labels on these, and they put the Z-axis here, which is fine. But I'm assuming that this here is Y. Oh, they do have the name, and this is X. So you're going to have to orientate your shape so that the X and Y axis match that one, which probably means you're just going to turn the shape a little bit to match them up. Now, this guy, question 12. We are not being asked to find the domain. We're only being asked to sketch what the domain would look like. So I'm busy writing this thing down. And it looks like it's a circle, half a circle from -2 to 2, half a circle from -4 to 4, or a whole circle, right? That seems to be the choices. Let's see if we can actually create what the domain looks like from this fella. Right, forget about this guy for a minute and focus on this guy. This function will only exist when the thing that is inside the brackets is greater than or equal to 0, right? Things inside square roots have to be positive, right? That's the thing inside the square root, and it has to be positive. Now, if I add an x squared and a y squared to be both sides, I get that. And if I do a little change in direction, that is equivalent to that. So what does that guy look like? Well, he's actually a circle of radius 2. And because it's less than or equal to 4, it represents all the points inside the circle. Are you comfortable with that guy? Now, what do you know about this? Well, it's only going to work when y is greater than or equal to 0. So if you're looking at this shape and you add another restriction to it, so right now you're saying you have to be points inside this circle. And now you're saying, that's not good enough. Y has to also be greater than 0. Now, if you do y greater than 0, aren't you talking now about the top half of the shape? And so that would be the domain, the top half of a circle from -2 to 2, which you no longer can see, but that's picture 1. Excuse me. How about this function? This is a 4th dimensional surface. So nobody is going to sketch that. Right? I couldn't, you can't plug that into GeoBra, it would just keel over and die, right? 4th dimensional surfaces, nobody knows how you draw those things. But I can tell you its domain. Its domain is that everything inside the square root must be greater than or equal to 0. So I'm going to do something like this guy up here. If you add the x squared, the y squared, and the z squared to both sides, what you're saying is 25 is bigger than that, which is the same thing as that is less than or equal to 25. Okay. Do you recognize what x squared plus y squared plus z squared less than or equal to 25 is? It's actually a sphere. Right? X squared plus y squared plus z squared. So you are looking for a 3-dimensional sphere of radius 5. And if you look at the pictures, there's 4 of them. The one that's here looks like that guy. And that's the answer you would pick. And that's pretty much the end of that section. So a lot of GeoBra, right? Where you just put it in and look. And then if you've got a surface, you can imagine what the contours would look like, right? A contour graph. And a little bit of domain. That's pretty much what we did. Any questions before we move on to our next section? Are we good? Right. So our next section is going to be 14.2. And 14.2, if I can come across it. Hang in here for a minute. Trying to find it. Here we go. Is limits. That's the wrong one. Limits. There we go. Right, this is a change in tack. We're not going to be doing GeoBra. We're not going to be visualizing things. We're going to be looking at how to find the limit of a multivariate function. So before I do that, let me give you a little recap on how you used to find limits way back in Calc 1. If I asked you to find the limit as x tends to 0 of 1 plus x over 1 take away x, it's actually easy to do, because if you can plug in a number and you get an answer, then the limit is that answer, right? But that's too easy, so you very rarely get a question that does that. You may get a question where you have this. Now, if you want to define the limit of this fraction as x tends to 0, would you agree that if you try and plug in 0, you get 0 on the top, you get 0 on the bottom, and 0 over 0 is called indeterminate form? It means we do not know the answer yet. The second method. Can you remember what L stands for? Second method.
A hospital.
That's the guy. So we're going to do the limit is La Hospital. All right, you're pronouncing it correct. I call it La Hospital because it looks like it's La Hospital, but I've been told by other people that it's La Hospital.
You say you get 0 in the denominator?
Oh, now you do. Right.
I had a
That,
I had a calc teacher who said for El Hospital, he said I can't pronounce it at all, so I'm just going to say that weird Frenchman that has his own rule.
wow. I just call them hospital. It's easier. Right. Now, if you differentiate the top, you get e to the x. If you differentiate the bottom, you get 1. And now you can put in 0. And for some reason, I keep picking answers that have a limit of 1. So let's do the third possibility, right? So you can do brute force. You plug it in. Don't think that's going to happen, really. It's too easy. La Hospital, yeah, that's pretty common. This one you might have had a problem with, which is where that is coming from. If you ever get a limit with a square root in it, as we have here, La Hospital is probably not going to be a good move, because La Hospital, you differentiate the top and bottom. And unless the bottom is nice, which it is here, would you agree that differentiating square roots tends to generate bad things, right? So you try and avoid La Hospital when you see square roots. What you're going to do instead is a totally different technique called the conjugate method. And the conjugate method involves us multiplying by a special version of 1 called the conjugate. And the conjugate is the guy with the square root, but instead of a minus, you make it a plus, right? That's it. Now, if you're multiplying by a special version of 1, which this is, aren't you not changing the answer, right? It's still worth what it was, right? It's just going to look different. So let's see what happens when we try that. These two guys, I'm not going to do anything except write them down again. And I suggest that you do the same. The guy that has the conjugate next to it, you should multiply these out. Now, you're going to trust me on this one. If you multiply this guy by this guy, you're going to get x plus 7. And you multiply them, you're going to get minus 9. Can you just trust me that if you FOIL it out, all the square roots kill each other off and you're just left with these two guys, which in turn simplifies. And that's good because it should. Still with me? Now, do you see anything nice that can happen here?
Cancel out the x minus 2s.
Yeah. So I'm just going to do that. Of course, when you cancel something out, you leave a 1 behind if it's all gone. So we're now looking at that. But here, I can now plug in x equals 2. And what I will get is 1 over the square root of 9 add 3, 1 over 3 add 3, and so the answer is 1/6. So those are the main strategies that you would have used in Calc 1 to find the limit of a fraction. Are we good? It's just a kind of summary of the past. So what is our limits going to look like? Well, here's an example of question 1. It's going to be the limit as xy becomes 0, 0. So you notice it's a two-dimensional limit. It's not the limit as x tends to 0. It's not the limit as y tends to 0. Essentially, isn't that the limit as x tends to 0 and y also tending to 0, right? It's two things both converging to 0, two variables. And the guy that we've got is that guy.
I have a quick question for
Yes.
Professor. Is there a reason why that the arrow that's pointing in the limit has like a little base to it?
Yes, because I like it.
Okay.
That's all. It's just pretty. I think it looks pretty. It doesn't need one. I just put it in. So stop picking on me. I'm getting very self-conscious. You're going to tell me in a little while, why do you put those funny little strokes through your sevens?
I actually I do that as well.
Okay. Do
Yeah.
you put strokes through your Zs?
Actually, yes, I do.
Now,
Yeah.
I do that because it looks too much like a 2, right? I do that because a lot of people 1s and 7s can look really similar,
Yeah.
especially if you make the top bit. I also do that when I do S's. Have you noticed? Because S's look very like 5s, don't they?
Yeah.
So that one is just cosmetic. Right?
Okay.
It would be totally fine with an arrow.
I thought it was just something to like represent like X sub 1 or something.
No, it's just pretty. Now, this is a totally new world. We've never looked at double integral, right? Double limit, right? Two things becoming 0 at the same time. You can't plug x0 and y in 0 here. If you did, would you agree you just get 0 over 0 in determinant form? You cannot do L'Hopital on it because doesn't L'Hopital need one variable, not two? So kind of L'Hopital's out the window. And there are no square roots here. So evidently we can't even use the conjugate yet. So how do we tackle these questions? We take a slightly weird but successful trick. We just assume that y can be written as a multiple of x. Now, if x tends to 0, would you agree if y is equal to mx, won't y tend to 0? It's essentially heading towards the origin along a line called mx. Now, m is just any constant, right? It's just treat it like a number, right? A fixed value. Now, once you do that, you now change your limit. It now becomes the limit as x tends to 0. And x to the 4 is good. Take away 30, mx squared. And on the bottom, x squared plus 15 mx squared. Have you noticed that what we've done with this trick is that we've eliminated a 2-variable limit and converted it into an equivalent 1-variable, right? X tending to 0 limit. And that's good news because isn't that the kind of limit we know how to get? Right? I can find limits and things like that. Now I'm going to take it a little bit further. And that times itself gets you negative 30 m squared x squared. Style points are vital in these kinds of questions. And there's a little kicker in the tail when we're finished. So far, so good? Are we good, guys? Right. Anything you can look at the top. Is there anything you can take out as a common factor?
Just an x squared, looks like.
Yeah. Now that leaves me with an x squared take away a 30 m squared, and take out an x squared here, and it leaves me 1 plus 15 m squared. Are we good so far? Right. Anything I could do to simplify this then? Not meant to be a trick question.
Cancel X squares.
Yes. So what we're left with now is that the limit of x tends to 0 of this fraction should generate the same answer that that would do, right? Now, if you make x 0 here, you end up with negative 30 m squared over 1 plus 15 m squared. We're happy 0 squared just gets you 0 and it disappears. Now, here is the kicker in the tail. Remember, this assumption up here is that y is a multiple of x, right? It's 2x, it's 5x, it's 10x, right? Now, if I make m 2, won't this answer be one number? If I make it m equals 10, won't it be a different number? And if m is 40, won't it be yet a different number? In other words, for any given value of m, won't this be a different answer? Now, what does that mean? It means there's no limit. If you do this process and the answer is 42, the limit is 42, right? If you do this process and the answer is 0, right? There's no m's, right? They all disappeared, right? And you just get 0, then the answer is 0. But if you do this answer and what you're left with at the end is an expression that contains m's in it, then you have no limit, and we will write down DNE for the limit does not exist. Are we good? So the assumption is that if this is not a number, the limit does not exist. If this is a number, the limit is whatever this number is, right? Right now, this is not a number, a fixed number. Isn't that a number that changes? If you made this 2, if you made this 4, you get a different answer.
If we had a question on the midterm or the final, for instance, in this format, would the negative 30 m squared over 1 plus 15 m squared, would that be sufficient enough work, or would you want us to keep going?
The only keep going would be the limit does not exist.
Okay.
That's your final conclusion.
Yeah.
Don't leave me hanging by just stopping there, because now I don't know what your conclusion is, right? Tell me it means does not exist, and that's it. Right. Let's see if I can find an example where you get a number, right? You'd like to see an example with a number. Let's see if I can change this one a little bit. Let's do the limit as x, y tends to 0, 0 again. And I'll use the same guy. I'll just make a little change. Okay, so you notice the only change I've done is made this y to the 4, right? Now, we know this limit, because the answer contains m's in it, does not exist. Let's see what happens in this one. I'll make the same assumption that y is equal to mx, and I will do the limit. Oops, I don't need brackets now. The limit as x tends to 0 then, of x to the 4, take away 30, mx to the 4, all over x squared plus 15 mx squared. This guy is x to the 4. This guy ends up looking like that. This guy, and we get that. not that dissimilar from this line. Now there's a little bit of difference in this line. Would you agree you can now pull out x to the 4 as a common factor? You agree? X to the 4. That's a little bit different. Right here it was only x squared. Now the bottom is still x squared. Now when I do my cancelling, won't I still be left with an x squared? So that's a little bit different. So we now have the limit as x tends to 0 of x squared 1 take away 30m to the 4 all over 1 plus 15m squared. Are we good? Right, now let's make x 0. Technically, you get 0 times this guy all over this guy. But isn't that answer 0? 0 times this guy is 0, 0, 0 on the top, divided by this guy is still 0. So we have a limit, and the limit is 0. You see the difference, just tweaking one piece of the puzzle from a limit doesn't exist to now a limit is, in this case, it's 0. Any questions about this process of turning it into a single variable limit that we know how to deal with from the double variable limit that the question started off as? Are we good? Okay, then let's show you a ugly one, which is a version of question 3. And in question 3, it's the limit as xy becomes 0, 0. And it's x squared plus y squared over the square root of x squared plus y squared plus 36, take away 6. Can you trust me that when you plug 0, 0 in here, you get 0 over 0 and we're stuck? So I'm going to go let y equals mx. And let's see what we now have. It's going to be the limit as x tends to 0 of x squared plus mx squared all over the square root of x squared plus mx squared plus 36, take away 6. Okay, that's where we are right now. Do you notice that square root with the -6 thing going on? See it here? Doesn't that lend itself to the conjugate method? Right? You see a square root, think conjugates. So here goes. The square root of x squared plus m squared x squared plus 36, add 6, top and bottom. So we now have the limit as x tends to 0. The two top terms I'm not going to do anything about. But if you multiply this guy by this guy, can you trust me that eventually you get x squared plus m squared x squared plus 36 take away 6 times 6, which is 36. Now, if you don't believe it, FOIL it out and you'll get that answer. So it looks like we might have something that we can work with here. X squared plus m squared x squared times a big ugly square root. And these two kill each other off, and we are left with m squared plus m squared x squared. All right, pause there for a second. Do you see anything nice?
X squared plus m squared x squared.
And when you do that, isn't there essentially one left behind?
Yep.
When one is on the bottom, it's better just to think that you don't have a fraction anymore. And so what we have is x squared plus m squared x squared plus 36, add 6, technically all over 1. Now at this point, can't I just make x 0? And let's see what we get then. We get nothing squared, m squared plus nothing, add 36, plus 6, the square root of 36, add 6, 6 add 6, the limit is 12. So we actually got a number for a change. The limit is 12. How are we doing with that guy? Any questions?
Nope.
Is this y equal thingy bob as a trick working for you? Right. You do this, you turn everything into x's with some m's. You then, tidy it up the best way you could, cancel, whatever. And if you're left with a number 0, that's a limit. If you're left with number 12, that's a limit. But if you're left with anything that's got m's in it, right, then that means the limit does not exist, right? So it tells you when it's 0, it tells you when it's a number like 12, and it also tells you when it doesn't exist.
What is that process called? Is there like a
name for it?
name?
I don't know of any. I'm not saying there's not a name, but I don't know of any. How are we doing? Can we see the next one? Okay. The next one is a version question 4. And we have x, y to the 8 over x cubed plus y to the 12. And we'll go for the y equals mx trick. And this gives me the limit as x tends to 0. And we have an x and we have an mx to the power of 8. And on the bottom, we have an x cubed plus a mx to the 12. And this is going to be the limit as x tends to 0 of x times m to the 8, x to the 8. And on the bottom, I have an x cubed plus m x to the 12. And I should put a 12 here as well, shouldn't I? How's it working? Okay, so tidy it up a little bit more. I have m8 x to the 9, and I can pull out an x cubed here, and I have a 1 plus m to the 12. And cancel. Got that guy. Okay. And we are looking at, oops, I just killed the thing off. I'm just going to check the answer there. Essentially here, don't you get 0 over 1 plus m to the 12, which is 0.
I think I'm missing something. So where did the x to the 12 go? Oh, from the denominator.
Oh, the 12? Oh, I should put it back in, shouldn't I? If you pull out x to 12, there should be a 9 left over. So that gets me what? 0 over 1. That still gets me 0. If you make x 0, the top is 0 and the bottom is 1 plus 0. And that gets me 0 over 1, which is still 0. So I made a mistake there. That is, the bottom line should have said x cubed, 1 plus m to the 12, x to the 9. Right. But it still ends up being 0 when you're finished. Okay, we got that one I made a meal of. We got one more, and then we're looking at something different. And this one is a version of question 5. And I have an x squared plus y squared plus z to the 4. And I've been picking y equals mx every single question, only because it's easy. Do you know theoretically you can do y equals mx squared, mx cubed, m square root of x? You know, anything would work, right? Now, I'm going to do y equals mx. But that's not enough. What else could I do?
Can you find a Z?
And what would I do with z? Because I've got 3 variables here, and I do not want to try and do 3 variables. Don't I want to have 1 variable? So what could I make z equal to?
Could it be mx squared? I don't know.
Oh, yeah, actually anything would do. But since I'm lazy, I'll just call it mx. Now, if we put all of that together, we're going to get the limit as x tends to 0. And it's going to be x, oops, there we go, x, y, plus 4, what's x? Y is mx, and z squared gets me that guy, plus 6x, and z gets me mx to the power of 4. And on the bottom, I have an x squared, I have an mx squared, and I have an mx to the 4. Now, if this particular combination doesn't work, I can make any assumption I want, I guess. I could make it x squared, like you said, and see if that would do something there. but I have mx squared. I have 4 m cubed x cubed, and I have 6 m to the 4 x to the 5s. And here I have an x squared, an m squared x squared, and an m to the 4 x to the 4. Are we good so far? Are you comfortable with the pieces? Right. The best I can do is pulling out an x squared from the top. And the best I can do in the bottom is also to pull out an x squared. Are we okay with that line? Now, as we'd
So
expect,
you don't pull m's out, just x's.
yeah, just the x's. The m's will sort themselves out later. So pull out x's, x squared, x cubed, whatever the best you can do. And now I'm left with these guys. And you're right, there is a common factor on the top with an m in it, but I don't really care about that. And there's nothing on the bottom that would be counted as a common factor. Are we happy about that line? So far, so good. Now, we can make x equals 0. And so I get an m. That guy is nothing, and that guy is nothing. Because isn't m cubed times 0 still going to get you 0? And isn't 6m to the 4 times 0 cubed still going to get you 0? And on the bottom, I'm going to get 1 plus m squared plus some zeros. And so the limit that we got by doing this particular trick is this guy. And what's the conclusion if the limit contains m's?
Does not exist.
And we are finished, and we move on to our next question. Now, can you imagine in a different world, we might have got 0, right? When we plugged in x equals 0, the top became 0 and the bottom was 1 plus m squared. But if that happened, wouldn't the answer still be 0? In a different world, can you imagine the top ended up being that? But wouldn't that become 1? So the answer would be 1. So once you make x 0, whatever you've got will decide your result. This is as good as it's going to get. This contains m's. The answer does not exist. This situation got you 0. This situation got you 1, right? Are we good with that? We move on. Okay. The next, it's actually a short section, so that's good. If we get this finished, we'll be finished for today. And we're about halfway through. In question 6, we have a multivariable function, which is equal to that. And then it says below, f is discontinuous at, and it has an x equals, and a box. When you look at this function, discontinuous is essentially values where the function doesn't have a calculatable value. Would you agree that when x is equal to y or y is equal to x, wouldn't this become 1 over 0? And e to the power of 1 over 0 is bad news. You agree with that? So when would this function have a problem? This function is going to have a problem when x is equal to y. Does that make sense? If this was x minus y squared, wouldn't this function have a problem when x is equal to y squared? Now, if you put that into GeoBra, you would see some really weird things. You know, it's like somebody took a surface and ripped it with a knife and took one half of it and pulled it up the way, and the other half they twisted it some other way, right? Along the line, y equals x, there'd be a distinct breakage in the shape. Can you imagine one plate's going up and the other surface coming down? That's what it would look like. It has a problem. Now, how about this function? We're being asked the question the other way around. We're not being asked to tell us where the bad guys are. We're being asked to write down when is this function okay. So we're being asked to write down when the function is continuous. So here is its domain. And it's a set of all points x, y, such that in this function, where is the bottom? Or I'll just give the answer. I was going to say, where would you find a problem? Well, if you've got a fraction, isn't it when the bottom is 0? Right? You don't want a fraction to have 0 here, because that's going to lead to something divided by 0, which we know is bad news. So if a function is going to be in the domain, you have to make sure that the bottom isn't 0. So if you rearrange this guy and you make him equal to 0, it's another way of saying that guy, right? Now, if I don't want it to be 0, don't I just make sure that x squared plus y squared is never equal to 1? And so, oh, well, let me show you. This is what it looks like in the homework. This is how they kind of set it up. Here is the my wife just gave me some work to do. That was nice of her. Right. Oh, here is. I go away and hate answers. Right. Let's try that again as if we haven't seen it. Okay. Here is the question. In this particular case, the number is now changed to 2. But basically, as long as x squared plus y squared is not equal to 2, you will be able to evaluate this function, right? As long as the bottom isn't 0, and that will only happen, right, as long as x squared plus y squared is not equal to 2. Right. Now we got some limit guys to worry about. I'm not going to bother with 10 because we've covered that, but let's talk about 8 and 9 because we haven't. And we have to adapt it. So we're going to, I'll write the question down. The limit is x, y tends to 1, 2. And we have 6x cubed take away x squared y squared. And that's question 8. And question 9, it's the limit as xy tends to 1, 2. And this time, it's a really ugly fraction. Right. So these are going to be our last 2 questions. And basically after that, we've covered everything, I think. So let's jump right into the last 2 puzzles. Right. Well, I was wrong. At the start of today, I went and said, you're probably never going to get a question where you just plug the answer in. But I can see one. Can't you just plug x equals 1 and y equals 2 and you'll get an answer? 6 lots of 1 squared, take away 1 squared times 2 squared. 6 take away 4, the answer's 2. Wasn't that question too easy? Now, if you plug x is 1 and y is 2 here, I think you actually get the same answer, don't you? Let's check. Make sure I got the right one. 1, 2. Five take away 1 times 2. 1 squared plus 8 times 2 squared. So 5 take away 2, 1 plus 32. I make that 3 33s. Okay, I'm going to have to make one up that you actually have something to do, right? So here goes. Let's do the limit. Because they randomized the questions, I think I just got lucky and they randomized this one so that it wasn't a problem. If there's going to be a problem, don't you need 0 over 0, right? As long as you don't, if you have a number in the top and the bottom, you're kind of safe. So let me try and make one happen. So let's do y take away 2x plus 3. Okay, that would make the top 0. And let's do x squared plus y squared minus 5. Right, if you plug 1, 2 in here, do you get 0 over 0? You can't do it, right? Agreed? Put x equals 1, y equals 2, you get 0 on the top, you get 0 on the bottom. Now, I have to adapt my y equals mx. My y equals mx is only good when the thing goes 0, 0. If the thing goes 1, 2, I have to make y a multiple of m that has the property that as x tends to 1, the y goes to 0. Can you see as that becomes 1, what the answer be 2? So it's just, you pick this guy and you make it minus, you pick this guy and you tag them on at the end. So that is going to be my new transformation. I'm going to plug it in here. If I get a number as an answer, that's what the limit is. If I get something with m's left over, it means the limit does not exist. So let's see what happens. The limit as x tends to 0 of y take away 2x, add 3. And on the bottom, I have x squared plus that squared, take away 5. And by the way, that's 1. 1, not 0. So this becomes mx, take away m, take away 2x, add 5. And this becomes x squared plus m squared x minus 1 squared plus 4m x minus 1's, take away 5. Are we good so far? If I made a mistake, now's your chance to tell me. Because I think I just noticed one. Isn't there a +2 on this? So I now have mx take away 2x, take away m, add 7. And I have an x squared, this guy squared, and I got that guy. Okay, here it goes. I'm now going to make x equals 1. Let's see what we get. I get m times 1, take away 2 times 1, take away an m, add 7. And on the bottom, I get 1 squared plus nothing, plus some more nothings, take away 5. That kills off that. That gets you 5. And 1, and that guy, I believe, gets you negative. I got the answer. Negative 5/4. So the limit is negative 5/4. If there had been any m's left over, like negative 5 plus m, wouldn't that be does not exist? But if the answer is a number, that's what the limit is.
So what happened to the 4m? I guess multiplied by the x and then
That guy there?
minus, because I thought it was 4m. Oh, on the bottom, one below it,
Oh, here? Did I miss something? I could have missed something. What did I miss?
like right where your pen is now. Because I thought it was 4mx minus 4m minus 5. Which I thought so.
Okay, so if you
Do
take
I have that
this
wrong?
guy, I don't know, you might not. If you take this guy, you get that guy squared, you get 2 of them is 4. Oh, and you get a plus 4. So what does that get me? That gets me negative 1. I'm gonna check it. Yeah, that gets me negative 1, which means that gets me negative 1, which I get is 0. Oh, okay. I still got an answer. The answer is now just it does not exist. 5/0 is not a numerical value, right? It's an infinity, which will count as does not exist.
What I meant was that on the bottom when you have 4m times x minus 1.
Yeah.
I thought that would be 4m times x and then 4m times negative 1.
It
Some-
could be, but I just left it there because I know I'm going to plug in 1 and
Oh,
it's easier
x
to
is
see,
1. Geez, I'm sorry.
right?
Okay.
So it
Sorry about that.
basically takes care of those two guys. That's
Okay,
the
I
only
see what
reason I
happened.
did it.
Thank you.
Are we good? Right, so that's us. Oh, before I forget, and I'll definitely remind you on Wednesday, and I'll hopefully send some email out later in the week. What is happening this Monday, a week today?
A midterm.
Midterms. Now, midterms take on a different style because not everybody is free at any given time. The midterm is going to be it's going to be in Canvas. It's going to be in WebAssign, and it'll be called the midterm. But I need you to show me your working. So you are going to be writing down all your working, and then you're going to take pictures of it using a piece of software called Microsoft Lens, which I can give you a little heads up on that.
Microsoft what?
Lens, all right? Let me.
Can we just send it to you an email with PDF?
Yeah, you can do it any way you like. So some of you will put it into your printer and scan it and send it to me. Some will use this piece of software called Microsoft Lens, which basically means take pictures and it converts it into a PDF, right? Some of you will find other ways of getting it to me, but I need to get your working. So let me see if I can find it, don't I?
You just need to see our work, right?
Yes, I need to see your work. And there are 2 reasons for that. The first one is to prevent cheating, because you could just write down somebody else's answers. And the second is more important than that. Have you noticed that you could get something 90% right, but when you put the answer in, WebAssign says you're totally wrong because the right answer was 8 and you said 10. If I
I'm really
could see
glad
your
you
work,
said that.
Right. So when I see you're working, because the midterm is so important, I can't do that for every piece of homework, and I certainly couldn't do it for every test that we do. It would just be, overload. I wouldn't be able to do it. But I definitely find it important for the midterm and the finals that we do that, because they have so much your percentage. So when you send in your working, so essentially what will happen on that Monday, the midterm will be available. When it appears, you will basically do your working, and then you will send it to me. You can plug in the answer into WebAssign if you like. I don't care, because I'm actually not going to look at that. I'm going to look at your working, and I'll be grading it from the paper that you send me. Right. Now, if some of the questions, and they could well be, here is a picture, which one of the four is the right picture? Your answer will be question 7, it's picture 2. Right. There won't be any working for that, right? Because, you put it into GeoBra and you looked at it, right? But I can't emphasize this enough. If there's any calculation, any algebra, anything that you've done, even if normally in homework you skip it over because you have 12 questions to do and you don't have the time, break that rule for the midterm. Show me every line of working, because if you go wrong, at least I can see what you've done and I can tell if it's the right process. If you cut out too many lines, I don't know. What was it? Yeah, you say it's 42, but I can't tell why you got 42 or what you did wrong to get to there, because there was 3 other lines that should have been there that you didn't tell me about, and I can't be a mind reader. So
if we
and then-
make a mistake and we carry that mistake through the problem, we only get dinged for that mistake once, right?
yes,
So, I mean,
right.
like our
'Cause
procedure was correct, but the
that's
numbers
exactly it.
are
Yeah.
wrong.
Cool, I
So
like
I'm
that,
looking.
John.
Right, I'm looking at the process, because a lot of these questions, a +2 turns into a -2 because there's so much going on you forget it. Or 3 squared becomes 6, or an x turns into an x cubed, or all those little things. I'm looking at process, and you get, you lose points because it wasn't right, but you only lose points at that one place, right? And I will just continue the process and check it from there. It takes a lot longer to do, because if you make a mistake, then I have to work the question with the mistake that you made to see if you did do the rest of it correctly, which is why I don't do this all the time. Right, I did send you a report, so you should be able to see it. It's available now. So that'll be report week 4, and it should have online test 4 and all that fun stuff. Any other questions?
Do we have all of Monday to do the
Yeah.
midterm?
Because I don't know when you're working, so I can't really just say, it's going to be from 2 to 5, because it's going to be 3 hours, right? So when you don't click it until you're ready, but when you click it, there's a counter, just like a normal test, but it's going to be a 3-hour counter, right? And that is a little bit
How many
different.
questions?
Have no idea. I won't be making it until after Wednesday. But it will be covering everything up, including partial differentiation, which is what we'll be doing on Wednesday. So it's the first 5 weeks of work. And there's still going to be an online test on Sunday midnight, as usual. Yeah. Well, you get points for doing those. Plus, doesn't it give you practice at doing those? So it's helpful. Because typically my questions come from WebAssign, right? So you want to know what WebAssign looks like, right? So you get practice at it. Of course, you are allowed to drop 2 tests. I'm not suggesting you do it, but if you did decide not to do that test, it would be one of the 2 that I would drop. But
So
then
why
you
don't you
risk
do
it.
all the tests that way? Just out of curiosity.
Just time, just sheer time. If I had to grade it, especially when you make a mistake, I then have to do that question like it was a brand new question with a new number. If you said I've got 22 people and it takes me maybe half an hour to do each one, if I'm lucky, that would be just 11 hours, and there's just not enough hours in the day because I have to prepare, and my wife likes to talk to me occasionally, so I kind of need a little break. So that's it. I will do it for the finals. I do it for the midterms because they're important enough.
So there will be no recording your video or anything like that.
Well, I'll be here on Monday in case you just want to do it, and then you can ask me. I'm doing question 4. Are they wanting me to do insert question here? And then I can say, yeah, that's what they're wanting, or no, they're not. So I will be kind of for a couple of hours. I'll be here just because some of you may have last minute questions.
Okay.
And if you don't feel you need to, then you don't do it.
So what was the time again?
Anytime on Monday. I mean, it won't be until, I'm guessing nobody's going to do it before lunch, right? So it'll be 12 o'clock. And since it's a 3-hour exam, it has to be 9 so that you've got until midnight to finish it. But your
Okay.
job is to send me the minute you're finished. Don't send me it the next day, because then how do I not know that you haven't spent all night, going over it with other people and changing it? So you got to send it if you're finished at 8, then I expect to see it, by about 8:30. And I can tell by looking at WebAssign when you're finished, right? Because it'll tell me when you stop looking.
And if we have any issues submitting, so that maybe like it's more than like an hour getting it to you, should we let you know?
Oh yeah. One of the things that can happen is that the file's too big, right? When you send stuff, especially to my Olympic College email, there's a kind of limit that they allow a file to be. So the way around that is you send 3 files and you say first 5 questions, second 5 questions, last 5 questions, and you break it into smaller chunks. So if you try and send it and it doesn't, well, I know it hasn't. Don't know. You can certainly come and tell me about it by sending me an email, and I'll try and solve that problem. There are lots of different ways you can do it. As I said, Microsoft Lens is a lot of students have used it and found it reasonably intuitive. But if you've got a printer, sticking it in that works really fine. Some people just take pictures of it and send it to me as like JPEGs or whatever. That works a little bit.
So the
Slower.
test is going to cover everything that we've gone over so far, right?
Yep, including what we haven't done yet, which is on Wednesday, partial differentiation. So it's
And
5
would
weeks of
you-
work. Natalie?
Would you like these files through Canvas or through your email? Or is there a difference?
My email is easier. That's the drobertson@olympic.edu. But actually, I don't know what the limit on Canvas is. It might have a bigger limit. In other words, you can send me larger files. So if you try and send me an email and it just bounces, you might want to try Canvas as a backup. And then just shoot me a normal email saying, hey, you'll find it in Canvas. And I'll go looking for it there.
Okay, sounds good. Thank you.
Yeah, I think Canvas allows bigger files. I don't know why I know that, but I think it does. Any other questions? Right, we'll call it good then. Bye-bye for now, guys. See you on Wednesday.
Thanks, Professor.
You're welcome.